Hello everybody and welcome. My name is Richard Zoltek and I will be providing the video tutorials for this program. Welcome to Lesson 2. Last day we left off simply drawing basic lines and then erasing them and trying to understand how we save and back up files. So you can see on my AutoCAD when I opened it up, it automatically reviews the files that I've been involved in. Again, if you're working on a school computer, that information will not be available readily to you, but will be identified only if you're using your own personal laptop. All right then, let's start a brand new file. So we'll select File New, and if you haven't got the secondary menu open, you can click on the icon here that will allow you to hide or show the menu bar. In this case, mine is viewed, so therefore it says hide, and I will select File and New. And this will open up the AutoCAD template drawer, which basically has a series of files that have preset definitions to it. And we're going to click on the AutoCAD DWT. And with the extension DWT, what it does is allows you to make a copy of that file. So we actually don't open the DWT file. It automatically knows that with that extension, it's creating a copy. Today's lesson is about talking about how to communicate with AutoCAD using the different coordinate systems. There are three involved in this program: the absolute, relative, and polar, and this information is available in the Lesson 2 folder, so you can review that as we go along. Now, the reason we need to learn this is it allows us to communicate with AutoCAD using the different type of coordinate systems. So when we draw a line, we can draw with extreme accuracy, knowing one of the three systems is being applied each and every time. Absolute refers to an X and Y axis where we have a bottom left-hand corner piece of information and then we chart around an X and Y axis in order to find points. Relative positioning is identifying a start point and then moving from that relative position, giving directions in the X and Y axis. Polar coordinates is once again starting from a known position, but then moving around the diagram, understanding how we use the angular system. So I'm just going to move that aside. We're going to be referring to absolute coordinates first, and I'm just going to move this aside so when you look at this particular image, you can understand what we're actually drawing. In order to begin, we must first navigate this screen and understand how we're going to set up the screen relative to the drawing. The drawing is relatively small. It fits on an 8.5 by 11 piece of paper, and it is in imperial units, so therefore feet and inches are going to be employed here. We will also be looking at using other units like millimeters or metric system in our projects. So the first thing we're going to do is set up the page to help AutoCAD understand how we want to communicate what units we're going to be using. So we're going to type in the word units. You'll notice I don't click anywhere. I simply type in UNITS onto the screen. Here we go. You can actually see it being listed there, and it identifies immediately all the different commands that begin or have or contain those letters in them. So units is what I want to type in. Press enter, and this menu comes up which identifies the different types of units we can be working with. And you can see there are 5 different types. Architectural simply means feet and inches. So that's identified with interior design, architectural design, landscape design, any of those type of design uses. Precision refers to how the units are going to be displayed. So when we actually do measurements, it will measure and then display to that decimal place accuracy. Rear AutoCAD works to 16 decimal place accuracy. So we can have the precision all the way down to 1/256 of an inch. But it doesn't really refer to how precise the line is, simply how precise the measurement value that we see will be on our screen. So we're going to leave it at 1/16 of an inch. We're not going to change our angular values whatsoever. And you can see here, if we're typing in feet and inches, these are the acceptable methods of typing in that data. We can also identify here how we insert. So what's nice about this is if I have a drawing that's already finished in a unit format, whether it be metric or imperial, I can import it, and this tells me, okay, what units are you going to be importing those diagrams in? So there's a lot of information here. All that we're doing is changing the units from decimal to architectural and selecting OK. So at this time, we've identified how we're going to communicate, and that's based on the drawings that we worked with or the drawings that I showed previously in absolute, relative, and polar coordinates. Now I'm going to identify my drawing area, and this refers to limits. So I'm going to type in the word limits, L-I-M-I-T-S, and press enter. You'll notice I didn't click anywhere. I just simply started typing. And it's asking me to set the page. So when we set the page, we identify the lower left-hand corner and the upper right-hand corner, and it creates a rectangle within that. So you can see at the bottom of my screen here, it's asking me, what is the lower left-hand corner? And we always identify that as 0, 0. Now you'll notice it says already 0 feet, 0 inches. That's because of the units we selected. If we had selected decimal, it would simply say 0, 0. So now that we've selected feet and inches as our units and we're setting up our page, the bottom left-hand corner is 0, 0. So we simply press enter, or the enter key, and it accepts that value. Now it's asking me for the upper right-hand corner. And as I mentioned, we're going to be drawing basically on an 8.5 by 11 piece of paper. So I'm going to round that off to 12 by 9. Now I'm going to type in 12 first, because you always type in the x-axis, or the length along the bottom. So here we'll type in 12, and you can see that information is coming up on my screen, comma, 9. You'll notice I didn't click anywhere. I didn't have to click inside the menu bar or anything like that. I simply started typing, and it automatically comes up with all these different elements. So it's 12, 9, and I press enter. Now visually, I don't see anything. In the command prompt, it's telling me what I've changed. In terms of the limits, it says exactly what was already there, because that was the default setting. But now if I want to visually see that page, I'm going to go down into my display grid here. These are the different settings that we can adjust our page to, or how the program reacts to us. And you notice to the right of that it says snap mode off, snap mode F9. There's a little arrow. Just click on that. And when you click on that, you get this menu. We're going to click on Snap Settings, and we get this menu. So there's a number of different options here. And this is, again, we're just setting up how we communicate. Once this is deployed into the drawing, every time you open the drawing, these are already preset. So we only do this once in order to set up our page. Now, if our page size changes, we'd go back in here in order to identify that change on this menu as well. For the purposes of this exercise, and you can see how it will change how we view the page, remove Adaptive Grid and Display Grid Beyond Limits, and select OK. Now why did we do that? Because this is our actual page, our 12 along the bottom, our 9 along the side. So if we're renovating a room, or we're designing a room, what we'd actually define is how big that is in actual sizes, and set up our limits to reflect that, so that we can easily navigate between the drawing. So what do I mean by navigating through the drawing? I want to zoom this to be full size. Again, I'm not clicking anywhere, but I will type in the letter Z, enter. Now you can see Z, as soon as I type it, it gives me the prefaces to what Z refers to, zoom, enter. And then we're going to type in A. Now why A? Look at the bottom of our screen. At the bottom of our screen, it says zoom, all, center, dynamic, all those different options. A refers to all. So I'll type in A and enter. And it fills that limit that we've set, 12 by 9, to our screen. So this gives us a good sense of scale, or size, or proportion. It's very easy to get lost in virtual space when we don't have a page that reflects what we're actually drawing on. That's the only reason we do this. We don't need to follow this grid or identify it. It just gives us relevance to the size of the space we're working in. Okay, at this point, we could save the drawing, because we don't want to make any mistakes or remove all the work that we've already done. So I'm going to select File. It's the first time we're saving this, so we're using the Save As function instead of the Save As. Now I've already got a series of lessons here, and this is lesson number 2. So I'm going to save it in this folder so I can refer to it at a later date. And we're going to call this coordinates. And the reason we're doing this is simply to identify what we've been doing in this particular file. So coordinates, we'll select Save. And now you'll notice that that information is at the top of our menu to identify where we've saved it, what we've called it, Now that we've set up the environment, we're going to be looking at the different coordinate systems. The very first one we're looking at is the absolute coordinate system. So if you want to pull out that PDF file that's called absolute coordinate, we're going to be looking at this screen to identify what is the absolute coordinate system referred to. Well, it's the basics of the program, and we use this only typically to identify our first location, and then we move forward from there. It's very much like surveying. X is along the bottom, Y is along the side, and this refers to graph paper and how we used to work with that. We can be using it for very quick sketches, but typically we don't. It's simply to identify how the grid is laid out. I want you to go to the bottom of your screen under the snap settings there, and I'm going to click on snap settings, and you'll notice that the grid that we've created is a default grid based on the limits that we set up, but it's really useless to us. So what we wanted to do is identify our coordinates and have it more reflective to the size of our screen and what we're going to be doing. So in the grid portion of this display, we're going to change this to 1 just because we're going to be working with 1-inch intervals, as you can see in the absolute coordinate PDF file. And I want a major line, let's say every 2. So it's identifying 2-inch squares. Again, adaptive grid and display grid are beyond limits are off. I'm going to select OK. So what does this reflect? Well, let's take a look at our absolute coordinates of where it shows you where to start, 2, 2, 2, 6, 4, 6, and so on. I'm going to click on the line tool. And when I click that on, I'm going to type in 2, 2 and enter. So I haven't clicked anywhere. I simply click on line and then type in 2, 2. And you can see where it's positioned us. 2 squares over from the left, 2 squares up from the right. So let's take a look at this grid in absolute coordinates to read this file and click in the different locations. So as I move my mouse up, it's giving me 2 pieces of information. You can see when I move it close to the 4, it shows 4 on the left side of the screen. It's actually highlighted so we could type in a value. You can also see it's given us a polar value, and polar values are something we're going to discuss at a later time, which is a distance and an angle. So straight up is 90. I'm going to try to get you used to it now, so when we get to that menu it'll make a lot more sense. And I'm going to click on the screen. Now this is not a very accurate way of drawing. It's to identify how this coordinate system works and how the screen is laid out. So I'm going to click on where it says 4, and you notice on the drawing it says 2 inches. So where am I? So you can see here when I selected 4, if I count the grids, I'm at 2 across and 6 from the bottom. That's what that absolute coordinates refers to. Now I'm going to go across 2 units and click in that position. So where am I? 4 from the left of the screen and 6 from the bottom. Now this is typical of how we used to create graphs, but really it's to identify how AutoCAD is laid out as well. X is along the bottom, Y is along the side. So here we're 2 down and 2 across. So if I go down 2 units and across 2 units, there's my position. Where am I in absolute coordinates? I'm at 6, 4. And then I can quickly move through the rest of this menu. And you can see I'm more or less guessing at these points. Now, the reason we're doing this is to identify a couple things. I'm just continuing to click right around the whole menu, and then I press enter. If I look at this and I zoom in on this, so how can I zoom in on this? There's a couple of methods. The easiest way is to roll your mouse. There's a wheel on your mouse. You can see how far I am off of that graph paper. That's not a very good way of drawing. Although the very first location that we typed in, 2, 2, so I'm rolling back out, and then I'm going to move my cursor over top of that first location and roll my mouse. You can see it's very accurate. So we need to be able to communicate with AutoCAD in a very accurate manner to be able to draw. All right, I'm going to press escape and enter so that we're all at the same place. Type in Z, enter, A, enter. And there it's zoomed to the screen. Good. This information we don't need, so I'm going to select it all. Now this is another way of erasing. I didn't click on the erase tool. I started at the bottom right hand corner and I clicked with the command prompt blank, click and then click, enclose the entire object, and then just press delete. It's another way of deleting. It's a faster way in some cases when we want to delete an entire mass of lines and line work. On the other case, where you have to be careful is it deletes every layer if the layers are on, so we have to be very careful on how we use that. Now I'm going to switch to relative coordinates. So if you go to your PDF files and it shows relative coordinates, here this is giving me information on how to work with relative coordinates using the same start point and working in a clockwise manner. That's really important. Counterclockwise, we'd be using different numbers from that relative page. So we're going to start at the bottom right hand corner, which is 2, 2 again. I'm going to click on line and then type in 2, 2. There is my absolute coordinate, or my absolute start position. Now I'm going to go clockwise, and I'm going to use the relative coordinate PDF to identify how I'm going to work using X and Y axis. So I'm going straight up along the Y axis. And how I know it's the Y axis and how I remember is Y, when you type the letter, has a tail that goes straight up and down, the letter Y. And therefore I know up and down is Y. You always type in X before Y. It's just using the alphabetical order. So you'll notice on the PDF file it says 0, 4, 0, 4. And enter. So let's make sense of that. I didn't change the x-axis, so that's why it's 0. And I went up positively. Up is positive, 4. So I typed in 0, 4. The next position is 2 to the right. So I'm moving across the x-axis to the right. That's a positive value. I'm not changing my y-axis value, so it's 0. So here I type in 2, 0. You notice I'm not clicking anywhere. I'm just typing. And that's really what's important. Now the next value is I'm going down 2 units. So that's negative along y, but I'm going to the right, or positive along x. So my value, again, I first type in x. So I'm going across 2. And then I type in y. I'm going down 2. So I'll type in 2, negative 2. Right? So 2 is the x-axis to the right. Negative 2 is the y-axis down. All right, this value up here, I'm going to the right along x 2 units, and then up 2 units along y. So I'll type in 2, 2. And you can see how this relative positioning is far easier to maneuver. The next one's 2, 0. Why? Because it's always based on the previous point. So all I have to know is from this point, where am I going next? So going down 4 units, but staying along the same x line, I'll type in 0, negative 4. Now this last spot, if I did this all in sequence, all I type in is C and enter, because it closed my loop. And that's a very accurate way of drawing to 16 decimal places, and that's what we want to maintain. Now, if you really want to understand this, start at 2 again, and this time go in the opposite direction, go counterclockwise. So that PDF file, all those values are incorrect, and that will help you identify whether you truly understand relative coordinates. Okay, so the last method we're going to work on here is referred to as polar coordinates. So I'm going to create a window around the drawing that I already have. Notice I didn't select a command. This is another way of quickly erasing things, and I'm going to press delete, and it's gone. Now, why do we have 3 different systems? Because we can't use one method on every drawing. We need to be well versed in all 3, primarily polar and relative, in order to draw quickly and accurately. So I'm going to click on the line tool. I have to start at the same point, and that's using absolute coordinates, which is 2, 2. Remember, polar and relative need something there because all positions are relative to the spot that you're starting. So we're using absolute to start. If I had our diagram there, I can click on an endpoint of a line and therefore just use polar or relative from there. So we're starting at 2, 2, just so that it looks exactly like the example that I have in PDF format. Only this time we're going to use polar values. So how do we refer to polar values? Polar values is a distance and an angle, and you can see that little diagram. There's the different angles around the 360 degrees that we draw. So our first distance is 4 units straight up. Straight up is 90 degrees. So how do we identify to the program that we're no longer using relative, but we're using polar? Well, we have to use the less than symbol. So let me show you how that works. If I'm going to move my mouse straight up, you'll notice that the little diagram box to the right shows you a polar value, and there's the less than symbol. And so you can see how we type values in. So we're going to go 4 straight up. All right, just by moving my mouse in that position, it reminds me of what straight up is, which is 90 degrees. So I will type in 4, hold down Shift and press the less than key. That's the one right beside the letter M, and type in the number 90. And there I have my distance. Great. Now I'm going to go 2 to the right. And again, to the right, if I move my mouse there, and I'm not suggesting you do this, but in the beginning it may help you. I'm going to look at there and say, hey, it's 0 degrees. Okay, I'm moving my mouse off that position so I can see it snapped to the correct location. So this is 2 less than, remember that's Shift and the key right beside the letter M, and then 0 and enter. Now, here's a condition where I don't know the polar value. The polar value is the length of the line. What I do know is the relative value. The relative value is 2 to the right and 2 down. So I'm switching methods. So how do I switch methods? It's just how I type. So here I'm going to type in 2 for x, comma, -2 for y, and enter. And there I have my correct position of 2 to the right and 2 down. My next position, again, I don't know that polar distance. It's some odd number, so I don't want to use polar values. I'm going to use relative values, and I know relatively it's 2 to the right and 2 up. So that's 2, 2, and enter. Now I can use polar or relative. It depends on which one you're comfortable with. So how do we decide? It's based on either comfort level or whatever information we're provided. If you're comfortable using X and Y, do so. If you're comfortable using angular positions, do so. In this example, we're going to stick with angles. So we're going 2 to the right or 0 degrees. So 2 less than, that's Shift less than, 0, enter. There we go. And now we're going to go straight down. So that will be 4 less than, straight down is 270. Now, why are we typing this in and kind of experimenting with this? You'll notice that the nice thing about polar values is every number I type in is positive. So even though this is 8 to the left, so in relative coordinates, it would be -8 along x. But in polar coordinates, it's a positive value. 8 less than, the direction is given by the angle. In this case, it's 180 degrees or 180, and enter. Once I've completed it, I press enter. Now, if I zoom in, all I'm doing is moving my cursor over a point and rolling my mouse towards the screen and then away from the screen. You can see it's absolutely spot on each of these positions using relative and polar coordinates. And this is what we're going to focus on, making sure our drawing is absolutely perfect. I'm going to leave this now and save it. So I'll select File, Save. Notice I'm not using Save As. Why? Because we've already saved it to a location. I'll click on Save, and I will click on the small x, not the top one, but the small one, and that will return me to the menu. And there's my diagram. That's the last view saved. With practice, you'll be able to understand absolute, relative, and polar coordinates very quickly. It's very important that you work with all 3 methods, although relative and polar will be the dominant methods you use. And based on the information that you'll be provided with on the drawing, or if you're on a job site, how you're measuring things out, that's the most efficient way of being able to draw. Well, thank you for joining me, and I will see you at next lesson.